Okay, hello and welcome. I am going to be going over static routes today, and we're going to kind of set up a basic network right here. I've already gone ahead and set up addressing on our ports, but that's it, and then turn some configs of the ports on, but I have not done any other configuration besides that. So what we're going to do is we're going to walk through setting up static routes, talk about what static routes are, and why we need to write them for our routers and how they kind of work. So in front of me we have a small, or what you're seeing on the screen, you're seeing a small topology. We have three routers right here. One on the left hand side, R0, one in the middle, router 1, and one on the right hand side, router 2. And then two PCs down below. So all in all, if we look at our networks that we have our 192.168.10.0 network. We have our 192.168.20.0 network represented in that green circle. And then we have two point-to-point networks right here, one in between router 0 and router 1, represented by the 10.0.0.0/30 network in red. And then we also have our other point-to-point link here, which is in between the router 1 and router 2 at 10.0.0.4/30. And I've gone ahead and put addresses on each of the interfaces that I've just marked right here. So our PCs are going to be sitting at 10.50 right here. So 192.168.10.50. Our other PC will be sitting at 192.168.20.50. Our gigabit 01 for this interface is 192.168.10.1. Our gigabit 01 over here is 20.1. And then I've just set the what the point-to-point link addresses are as well. So .1 on the gigabit 00, .2 over on the router 1 gigabit 00, .5 on G01, and .6 on G00. Okay, so again, all I've done is just set up some addressing here. I just need to set the static addresses on these PCs. Oops. We have our subnet mask, and then we're going to make sure that we have our default gateway as well. Remember, our default gateway is our doorway out of our LAN. If my PC doesn't have a default gateway, I can't leave my network, that little blue circle. So very important that that is set. So then we also have our other network over on our other PC. Again, setting up its default gateway, which is its doorway out, which is the G01 interface. And now, essentially what we have is we have connectivity within their LANs, but they won't be able to move beyond that. So if PC 0 wants to go up to the router, it should be successful. However, if it attempts to go over to another router, it will fail. If it attempts to go over to the other PC, it will also fail. And that is due to how traffic works right now in the routes. So right now, when the frame is built, the frame is being sent up to the router here, and the router is looking at the traffic. So in our scenario of, say, PC 0 here was attempting to ping over to PC 1 at 20.50, that frame would go up to the router. The router would look at the destination IP address of 20.50, and it would ask itself, do I know where that network is? And if we look at the routing table with a show IP route command, we can see all of the routes that this router currently knows. And the router, by default, only knows what's physically connected to it, so what it is physically touching. So at this point in time, from router 0's perspective, the only networks that it knows that exists are the networks that have a cable directly connected to it. So it only knows about the 10.0/24 network, and it only knows about the 10.0.0/30 network. It has no idea that this 10.0.0.4/30 network exists, or that this 20.0/24 network exists, because it's not physically connected to it. So that traffic, that frame, goes up to the router. Router looks for 20.50, and it goes, does 20.50 exist within any of these ranges? So does it exist within this 192.168.10.0/24 range? Well, no, it doesn't. Does it exist within this 10.0.0/30? No, it doesn't. So that network doesn't exist. So at this point in time, traffic gets dropped at the router because the router doesn't know where to forward the traffic to. So what our static routes do is essentially we are manually telling each of these routers that the network exists, and we're telling it how to actually get there. Now, this is only one way that we can actually write routes. In this case, this is a static route, so we're manually assigning it. There's another method as well called dynamic routing, and there's multiple different versions where the routers will intercommunicate with each other and share routes. So as opposed to us going in and having to manually tell each router every single network that exists, they will just share the routes in a dynamic fashion. But for this scenario, we're just going to focus on static routing. So again, how do we kind of write these rules, and how do we kind of set things up? One thing that I like to do is I like to open up a notepad, and I like to kind of outline and write out what routes we have to write and list out a couple of primary things. So in our case, we're going to look at, say, router 0, which is again this left-hand router right here. And what we're going to write out is our known networks. And in this case, again, our known networks are the networks that it is physically touching. So we can again see from the routing table, it knows about this 10.0.0.30 network and the 192.168.10.0/24 networks, because again, it has a physical cable touching both of those networks. So in this case, the networks that it knows are just that. It knows about these two networks. But then I also like to list out our unknown networks. And our unknown networks are going to be any networks that this router is not touching. So in this case, the routes that networks it is not touching are the 10.0.0.4/30 network, and it also doesn't know about the 20.0/24 network. So what this tells me is that I'm going to need to write two static routes. I need to tell router 0 that both of these networks exist if I want PC0 to be able to ping any of these IP addresses. So the one thing to kind of note that's very important though is this 10.0.0.4/30 network, that's an optional route. I don't actually have to write it in order to allow end-to-end connectivity, meaning that PC0 can ping PC1. But if I want PC0 to be able to ping that G01 interface at 10.0.0.5 or the G00 interface over on router 2 at 10.0.0.6, I do need to write this route. But unless I need to ping those interfaces, this is considered an optional route. It's good to do it though, because if I don't, and I'm trying to troubleshoot why things aren't working, this can make it a little bit easier for me to kind of troubleshoot and be like, okay, well, where is traffic failing? And I can be like, okay, well, I have this route, so I should be able to get to these points, so it can't be at that area. So I would say it's optional, but I would recommend doing it. All right. So now that we have these routes, we know that we have to write two static routes. The next thing that I like to do is I like to write out how, oops, my shift key isn't working very well. We'll just do this. We'll just write out how I'm actually going to write the network. So in this case, when where am I sending the traffic to next in order to actually get there? So in this case, what we're telling this router to do is we're telling it where to send the traffic to next. So what this is called is the next hop IP address. So if I'm router 0 and I'm telling this left-hand router and I'm trying to say, hey, I'm telling it 10.0.0.4/30 exists, and if you want to get there, you're going to hand it off to G00. So you're handing it off to your next router down the line. So in this case, the next router down the line then is the one that's directly connected to me. So on the opposite side of this 10.0.0.30. So I'm handing it to the next router in line to say, if I want to get there, I'm going to pass the traffic to this router. I don't know if 10.0.0.4 is actually on the opposite side of router 1 or not, but I'm going to be passing it off to that router. So we're going to be sending it to 10.0.0.2, which is router 1. So we're saying if router 0 sees any traffic destined for this network, so either .5 or .6, it will forward the traffic to 10.0.0.2, which is router 1. So now, same thing, if I'm going to be sending traffic to I'm telling router 0 that 192.168.20.0 exists, and that if I want to get there, I'm also going to be sending traffic over to router 1. Again, I don't know how far away this 192.168.20.0 network is from router 0's perspective. I just need to tell it where the next destination is. So and then I'm hoping that whoever I'm passing it off to next knows where to forward it to beyond that. So in this case, I'm also going to be sending this traffic to 10.0.0.2, which is my next hop. You're not skipping over to router 2, even though router 2 is attached to it, because from router 0's perspective, it doesn't know that router 2 exists. So it just goes, okay, well, where do I send traffic to next? I send it to my next hop, my next neighbor that I'm physically connected to. So hopefully that makes sense. So we set that router up, and now the next thing that we'll do is we'll do basically the exact same thing. We're going to list out router 1's known and unknown networks. So this is that middle router now. So its known networks are the networks, again, it is physically touching. So it knows about the 10.0.0.0/30 network, and it knows about the 10.0.0.4/30 network, because those are the two networks that this router 1 is physically cabled to. It is not touching this 10.0 or the 20.0 networks highlighted in blue or green. So we have to tell it that those networks exist. So those are our unknown networks. So unknown is 10.0/24 and 192.168.20.0/24. And then we need to tell it, oops, we need to tell it how to get there. So in this case, for router 1's perspective, in order for router 1 to get to the 10.0 network, it's going to send traffic to its next hop, which is in this case, let's pick yellow. So yellow doesn't really work very well. Never mind, yellow's a bad color. pink. So in this case, router 1 here is going to forward traffic over to router 0, specifically its next hop of 10.0.0.1, and we're sending it to that specific interface G00. We're saying, hey, if router 1, if you see any traffic that's destined for anything within this network range, send it over to router 0, your neighbor that exists at 10.0.0.1. So that's router 0. And then if it needs to send traffic over to the 20.0 network, it's going to send it to its neighbor over at 10.0.0.6, that G00 interface. So it's forwarding it over to router 2 there. So again, then we do the final one, which is router 2. And in this case, its unknown networks are 192.168.10.0 or its known networks are 20.0/24 and 10.0.0.4/30, because again, it's physically connected to those two networks. Its unknown networks are the 192.168.10.0 and the 10.0.0.0/30 network. So again, now we're going to go through the same role of, well, where does it forward traffic to next? So if router 2 wants to communicate to the 192.168.10.0 network, it sends it over to its next hop, its neighbor, at the 10.0.0.5, that gigabit 01 interface of router 1. And then also the other network is, if it wants to reach to the 10.0.0.0/30 network, it would also send it to its neighbor at 10.0.0.5, which is still router 1. So again, by writing it out this way, it kind of is longhand, but what this has done for me is it tells me that I now know on each router how many routes I need to write, and then how I'm actually going to write these routes. So to give an example of, if I wanted to write the actual rule that's right above here, I would say IP route 10.0.0.4. I'm telling it that that network exists. Then the mask, which is telling it how big that network actually is. And then I'm stating how to get there, which is what we just specified right there, which is at 10.0.0.2. So again, what we've done by writing it out this way is essentially writing out logically for what the command is. So we're stating IP route, we're telling it what network exists, which is the 10.0.0.4. We're telling it how big that network is, which, remember, we've talked briefly about this before, which is 255.255.255.252 is the subnet mask. It's also the /30 is a shorthand version of representing this. And then the 10.0.0.2 is the next hop IP address, who we're handing it off to next for actually sending traffic to. So then we'll look at our route for the other area as well. So our rule for right here would be IP route 192.168.20.0. We're telling it how big that network is, and we're telling it how to get there next. And we do the same for each of these. And so writing it out this way helps me for actually going in and actually writing out my rules. So now when I go into my router here, now I can know, in global configuration mode, I can write out these rules and actually go, okay, well, here's what I'm going to do. Now, I've already written them out, so I'm just going to copy and paste them in because I don't want to type them out again. And now I've written my 2 rules for router 0. So we can go over to our router 1 here, go into global configuration mode, and same thing. We know that we have to write 2 rules. We have to tell about the 10.0 network, and we have to tell about the 20.0 network. So we'll write our routes of IP route 192.168.10.0, how big the network is, which is a /24, also known as 255.255.255.0, and then how to get to the 10.0 network, which is send it over to router 0 at 10.0.0.1. Then we also have to do the same thing, which is tell it about the 20.0 network, and I just pressed up on the arrow key and just modified the prior command. And now we have our 2 routes for router 1. And then our final route that we need to worry about, or router that we need to worry about, is our router 2 here. And same thing, we'll go into global configuration mode, and we'll write our routes here. And we're going to tell it about the 10.0 network, how big that network is, and if I want to get there, we send any traffic over to router 1 at 10.0.0.5. And then same thing, we're going to tell it about the 10.0.0.30 network, and same thing, we would send it over to router 1 at .5. So with all these routes in here, now we can kind of verify and go, okay, well, did this actually work? Do I know now all the routes that I need to know? And we can use the show IP route command from our privilege exec mode to check and see, okay, well, did the routes actually get entered in? And in this case, we now do see 2 static routes in here. Now, the one thing to note is that the static routes are only going to be entered into our routing table if what we've specified, say what the next hop is an active link. So in this case, I'm specifying that I want to send traffic over to 10.0.0.2. Well, my router will verify, okay, well, 10.0.0.2, well, that exists on the opposite end of my G00 interface, because we know this from our route right up here, and that its local 10.0.0.1 exists on G00. So if this link isn't active, then this network or this static route won't get added in. So that's one thing to kind of note or remember, is that these routes will only get added in if you've entered them in correctly, and only if the link, the next hop or router that you're handing it to next, is active as well between those 2 signs. So that's kind of the important thing, grand scheme of things. So now if we go back to our router and we attempt to ping from PC 0 over to PC 1, traffic should work. Now it will fail the first time, and maybe the second time just because of ARP. All I did is just double click on this fire button, and it is now successful, and its traffic's actually going back and forth. Now if we want to just extra verify, we can ping through the actual command prompt at 20.50, and everything seems to be working just fine. So yay. Now we can also verify that I'm also able to ping between, say, router 1 and router 2. And remember, I'm on PC 0 down over here, because we did write a route for that as well. So I should be able to ping to 10.0.0.6, and I'm getting a reply. So all traffic seems to be working. So hopefully that was helpful for going over static routes a little bit with you. If you have questions on stuff, as always, feel free to reach out. Thanks. Bye.